Dear colleagues, I would like to present our study on the topic use of STEM technologies in the context of training Ukrainian computer science teachers in accordance with today's social needs and challenges. Its authors are researchers from Vasylenko National Pedagogical University, Nadiia, Balyk, Galyna, Shmyger, Yaroslav, Vasylenko, and me, Vasyl, Oleksiuk. This study is dedicated to the memory of Yuri Ramsky, one of the founders of the methodology of teaching computer science in Ukraine and the supervisor of two authors of this article. Ukraine, like many other countries, faces the challenges of rapid technological development, innovation, and digitalization. Research on the use of STEM technologies in the training of computer science teachers can bring such benefits, improving the quality of education, responding to the needs of labor market, development of critical thinking and technological skills of students, solving social challenges, and others. Therefore, research of the use of STEM technologies in the training of Ukrainian computer science teachers meets current social needs and have a significant impact on the quality of education. The training of future school teachers is an important task for many European countries, including Ukraine. Our university acknowledges the significance of training high quality STEM professionals and the adopting innovative teaching approaches. One of the main tasks in the development and implementation of the new bachelor's and master programs aimed to the development of research skills. The research focus of this article is to study the use of STEM technologies in the context of training competitive specialists to the social needs and challenges today. The research goal is to study the main trends of STEM education in modern university to identify the key component of the model of training teacher in STEM, to study the use of STEM technologies in the content of training competitive specialists by social needs and challenges of today in times of war. The main trends in Ukrainian university STEM education are as follows: interdisciplinary integrated courses, cooperation between university, STEM project with a social focus, STEM laboratories, STEM centers, internship and employment with IT companies, STEM mentoring programs, STEM incubators and startup centers, STEM festival and conference. National Pedagogical University is also implementing STEM approaches in its educational process. The Faculty of Physics and Mathematics train future computer science teachers using STEM approaches, and there is STEM Center support STEM discipline. We propose a model for future computer science training in STEM. The key component of the model are follow: target component, it contains social orders, industry standard, needs of student, content component, formed by educational programs, content of STEM disciplines, material for theoretical and practical thinking, active element that includes teaching methods, research activities, cooperation with scientific, educational and business institutions. Diagnostic and results component formed by appropriate method and the expected results of the implementation of the model. The implementation condition of our model are follow: educational training. This component covers professional education, including educational bachelor's and master programs, secondary education, computer science, and others. Teachers with interdisciplinary knowledge in the various STEM fields can integrate different subjects and create more holistic lessons. Pedagogical skill. This element focuses on the development and use of effective teaching methods that stimulate interest in STEM subjects. Preparation for the use of technology. It involves training teaching in the use of modern technologies to improve the learning process and engage students. Support for research activities. That includes the stimulation of scientific research through a creation of STEM research centers. Cooperation with the public and various institutions. It increases the intensity of communication on STEM education, promote ideas about STEM education among the public. During wartime, the authors adopt some curricula of bachelor and master degree programs, identified the current state of STEM curricula, and highlighted key topics that need to be adapted to the war. The theoretical material was updated to accommodate limited resources and practical examples from real life. Here some examples of specified courses where used STEM technologies. Course offered include methods of teaching computer science and STEM educational technologies, STEM project, fundamentals of robotics, fundamentals of cybersecurity, 3D modeling, 3D printing, and other. Another case of model application is educational, methodological, and technical support for STEM education. It formed by some courses, special courses such as STEM project, method for teaching computer science and STEM technologies, learning technologies, and others. Methods for conducting classes are aimed on the development of students' creative skills in solving practical tasks, projects, such and implementation of methods that promote the development of student creative abilities. To investigate the effectiveness of using STEM technologies in training competitive specialists, we created a questionnaire. The respondents were 35 first and second year master's students enrolled in the secondary education, computer science, and other programs. Of these, near 50 persons were female and 50 persons were male. The questionnaire comprised multiple questions group. They were formed as a 5-item Likert scale and determinate indicators of students' use of attitude towards STEM technologies, such as frequency of use of STEM technologies, the benefits and difficulties of using STEM, the effectiveness of using didactic methods and in STEM education, a student's goal in studying STEM, using STEM in future professional activities. We choose the factor analysis as a method for statistical processing of obtained data. To reduce the number of variables in the factor analysis, average values were calculated for the source variable. Factor analysis was used to verify the selection of a criteria group. These methods can also find other factors such as latent correlation between certain indicators in surveys. The statistical data was processed using libraries from the R language. Using the FA parallel function, we analyzed the numbers of factors to be retained in the subsequent factor analysis. Factors with an eigengames greater than or equal to 2 were selected as significant. There were 3 such factors. To conduct the factor analysis, we also used the factAnal function from R language. The obtained results are presented in the next table. We can see that our model is simple because it required a single load of each variable. The last section of factAnal function output shows the result of hypothesis test. The null hypothesis test is that the 3 factors in our model are significant to capture the full dimensionality of the data set. In our case, the p-value exceeds 0.75, which is greater than 0.05. Therefore, we have no reason to reject the null hypothesis. In three-factor model, the variable average score semester from the last row of the table is not significant. This indicated that in our study there are no relationship between the STEM technologies, STEM technologies in education, students' attitudes towards the STEM technologies and their academic performance. As a result of the analysis, we highlight the following factors. First, the value and importance of STEM to solving problems related to war. Second, effectiveness of the youth STEM teaching model and methods implemented by the university. Third, development and application of professional competencies related to STEM education. We can state that the factor identified through the questionnaire have some relationship to the component of our model. Factor 1 capture a student's wartime experience and their understanding of the role STEM technologies in Ukraine's current situation. In combined student opportunities to use STEM technologies in this difficult condition and the civil position. This factor connects to the teaching methods from active component model, which implies that project-based learning, research activities and cooperative learning approaches. Factor 2 focuses on effective teaching methods of STEM discipline in alliance with the model content component and active component, which underline effective teaching method for the STEM education. The model suggests that the content of STEM education programs should include scientific research and practical learning activities. The diagnostic and result component of the model identifies methods for diagnostic and effectiveness of STEM education, including surveys and evaluation of students' work. The third factor captures students' motivation and focus on STEM. It aligns with the model overall goal of training modern specialists and content component importance on educational programs. The model suggests using of active learning methods such as project-based learning. Students who are more motivated and interested in STEM are more likely to benefit from these types of activity. The diagnostic and results component of the model allows the use of various sets of methods for diagnostic the effectiveness STEM education, including surveys and evaluation of students' work. In accordance with it, we have changed the educational programs, the content of individual modules and requirements for student skill and organization of the educational process itself. The main objective of the model is to make educational relevant to our time. In this context, there are some ways to improve the educational process through the introduction of STEM technologies in the training of future teachers. For example, they include the following: expanding the experience of using learning startup to increase students' motivation for other disciplines, studying gender equality, named the wide involvement of girls and women in STEM technologies, inclusion in the design of art and design component of scientifically based methodological system for teaching various disciplines, inclusion of certain component of learning startup in student graduation work. The study gives ground to draw the following conclusion. The war in Ukraine is a global challenge to democracy, food security, economic stability, and international law. It has stimulated the development of technology in Ukraine, particularly in the areas of defense, energy, medicine, and cybersecurity. A successful response of these challenges requires specialists who not only have deep knowledge in their fields, but are also capable to interdisciplinary cooperation, data analysis, use of model technologies, and creative solution. One way to train such specialists is to use STEM technologies in higher education. For future computer science teachers, we recommend learning the basic of robotic, programming, 3D modeling, printing, drone technology, and others. Ukrainian students should take part in a research project aimed to developing new technologies for the army, infrastructure, rehabilitation, energy effectiveness, healthcare, and others. The result of this study demonstrates some effectiveness of STEM teacher training model and the use of the latest pedagogical methods. This approach makes it possible to identify effective learning and skill development strategies that will provide graduates with the ability to innovatively solve problems. That's all. Thank you for attention. Maybe you have questions.